Welcome to This Explainer. Today, we're diving into something wild, the totally hidden water footprint hiding right inside everyday items. Think about it. We're constantly interacting with pulp and paper products, your printer paper, cardboard shipping boxes, everyday office supplies. But did you know that just one single sheet of standard A4 paper can take up to 20 liters of water to produce? Yeah, 20 liters. Let's jump right into the data.
So to kick things off, grab a piece of paper, maybe a page, right out of your notebook. Now ask yourself, just how much invisible water went into making that? Because, it's super easy to think of paper as just being, wood fiber. But the reality? Water is literally the lifeblood of the entire manufacturing process.
Here's our roadmap for today. We're going to cover 1. The thirsty paper industry, 2. High baseline water stress, 3. The wastewater challenge, 4. Assessing corporate water risks, and 5. Closed-loop recycling systems. Let's get right into it. First up, Section 1. The thirsty paper industry. Okay, the sheer volume of water required here is absolutely staggering. I mean, a pulp and paper mill, it's essentially a giant water processing facility. They need massive, incredibly stable water supplies for 3 main things: materials processing, cooling down heavy industrial equipment, and generating steam for energy. Because of this extreme water intensity, analyzing how they manage it isn't just a nice environmental check, it's actually a critical look at whether the business can even survive.
Now, according to the SASB Sustainability Accounting Standards, we have to make a strict distinction between water that is withdrawn and water that's actually consumed. So a mill might pull millions of gallons from a local river, but consumption? That specifically means water that evaporates, gets baked directly into the product itself, or is just not returned to its original catchment area, like if it's discharged into the sea instead. Basically, that consumed water is permanently removed from the local ecosystem.
Which brings us to Section 2, high baseline water stress.
If you were to map this out globally, a really critical metric emerges. When a facility operates in an area where over 80% of the available renewable water is already spoken for, the World Resources Institute actually classifies this as extremely high baseline water stress. Think of it kind of like a community bank account that is constantly in overdraft. It's a huge deal. In fact, SASB standards require companies to disclose exactly how much of their water comes from these highly stressed locations.
So here's the crucial point. Operating in these stressed basins means the mill is directly competing for survival against local communities, municipal supplies, and other commercial users for a rapidly shrinking resource. If a drought hits, a pulp mill heavily reliant on that basin suddenly faces severe operational constraints. They might literally just not get the water they need to keep the machines running. Moving on to Section 3, the wastewater challenge. Let's talk about the water exiting a pulp mill, the effluent. Because what goes in must come out, right? And usually it's not clean. This process water is heavily contaminated with dissolved organic compounds and suspended solids picked up during the pulping process. Treating this wastewater before it ever touches the environment again is absolutely non-negotiable. Companies have to maintain incredibly strict control over the temperature and the chemical makeup of their discharges, otherwise they face severe regulatory backlash.
All right, Section 4, assessing corporate water risks.
Mishandling that thirsty intake or the polluted output triggers an absolute avalanche of corporate liabilities. These basically fall into 3 main buckets. First, environmental and operational risks. We're talking droughts completely disrupting supply, high supply costs, or aquatic impingement, which is really just a technical way of saying local wildlife getting pulled into giant intake pipes. Second, regulatory and financial risks. This means extreme volatility in water costs, strict discharge permits, and harsh withdrawal limits. And finally, reputational risk. Mishandling a shared, life-giving resource creates massive tension with local communities and non-governmental organizations. Definitely not good for business.
Which leads us to Section 5, closed-loop recycling systems.
Fortunately, to mitigate these massive risks, companies are fighting back with some truly ingenious water stewardship strategies, specifically closed-loop systems. If we trace the journey of a single drop through one of these modern setups, Step 1, it's withdrawn from the basin. Step 2, used for processing and cooling. But instead of just dumping it, Step 3 meticulously treats that effluent to remove those dissolved organics. Then, Step 4, it's brilliantly looped right back into the process water recycling system to be used again. These closed-loop setups are an absolute game-changer for hitting sustainability targets.
Just look at the critical evolution here. It's a huge difference. You have the wasteful, risky linear water use model, withdrawal, processing, discharge. versus the highly efficient closed-loop system: withdrawal, processing, purify, recycle, and reuse. By adopting this loop, companies drastically lower their overall withdrawals. It massively reduces their reliance on stressed local water basins, avoids those harsh regulatory fines, and fundamentally transforms them from a drain on the community into a responsible steward.
So, the next time you hold a simple piece of printer paper or, break down a cardboard shipping box, I want to leave you with this thought. When you look at that box, do you know if it was made by a brand prioritizing water stewardship or one draining a stressed basin? Ultimately, it all comes down to how these companies manage every single drop. Thanks for joining me on this explainer, and keep asking those big questions about the hidden impacts of the stuff we use every single day.